So today we're going to start Chapter 5, Section 3. Today we're going to learn how to evaluate trigonometric functions, and we're going to review our geometry skills. So again, an acronym that you may have learned last year in geometry is called Sohcahtoa. So the SOH, that's for the trig function sine. So the S is for the sine, the O is for opposite, the H stands for hypotenuse. The K in the middle, Sohcahtoa, the K stands for cosine, which is adjacent over hypotenuse. And then the toa is for the tangent, and it's opposite over adjacent. When we do any of these trig functions, we never use it for the right angle. It's always only for the two acute angles. So for example, if I were to draw a right triangle in here, again, the trig is only for right triangles. I could put in some letters here, A, B, and C. They will always reference an angle that they want you to do the calculations for. So I'm either going to only do it for angle A or B here. So if I wanted to answer all 6 of these in reference to angle A, the first thing you should always do is label the sides of your picture. So always label the hypotenuse first. It's always the side across from the 90-degree angle. Then the side that is opposite is going to be the side opposite to the angle that they're asking us about. So my opposite side is going to be over here. It's going to be the BC. And then the adjacent side, or the side next to the angle we're referring to, is always the adjacent. So now, one thing to remember, your adjacent side is going to be the X if you're memorizing the other way that we saw yesterday. And then the opposite will be Y. And then remember, your hypotenuse was always that R. So for the sine, if we're referencing angle A here, we're going to either memorize it to be Y over R, or if we use the Sohcahtoa acronym, it's going to be opposite side over hypotenuse side. For the cosine, and again, if we're using angle A, it's the X over R, or adjacent over hypotenuse. And then for tangent, that's the toa. We would use Y over X, opposite over adjacent. Remember the abbreviations here. Sine is going to be SIN, cosine is COS, tangent is TAN. Now, what you didn't cover in your geometry days were the reciprocal ones, but we are covering those now. So the reciprocal to sine is the cosecant, and that's abbreviated as CSC. And again, if I'm referencing angle A here, remember it's the reciprocal of sine, so we flip R over Y, hypotenuse over opposite, secant, abbreviated as SEC, and again, flip it, R over X, or you can also memorize it as hypotenuse over adjacent, and then cotangent is the COT, and that's X over Y, or adjacent over opposite. Again, a little review of your geometry. Now what we're going to do is figure out the 6 trig functions given a right triangle with some side lengths. So here's our first example. Again, it wants us to find the 6 trig functions. So sine, cosecant, cosine, secant, tangent, cotangent. Now, I don't have all 3 sides. Now, I know the right angle is a little hard to see, but this is the right angle. So I'm missing the hypotenuse. So what I can do here is I could either use the hypotenuse is r, I could use the formula I learned yesterday, r equals x squared plus y squared, and then square root it. But if you remember back to your geometry days, we could use Pythagorean Theorem. So remember, this is the hypotenuse, which is also your r. So you can either do this, or just do a squared plus b squared equals c squared. Let's add in some letters here. I'm going to say this is A, B, and C. So this is, I'm going to reference all 6 of my trig in relation to angle A. So I'm going to be filling in sine of A, cosecant of A, cosine of A, secant of A, tangent of A, and cotangent of A. So let me label my sides in relation to angle A here. So the 7 would be the opposite. The 24 is the adjacent. And again, if you want to memorize them with an X and a Y, I need to find R. So let me go ahead and fill it in. So I could either do Pythagorean Theorem, and I could do 7 squared plus 24 squared equals c squared. 49 plus 576 equals c squared. Add them, square root it, and your c, or your hypotenuse, is 25. Now, if you remember your Pythagorean triples, this is a common Pythagorean triple. If you prefer to use the formula we just learned, you can also do 24 squared plus 7 squared. You get exactly the same answer doing it this way as well. If you are aware that the r is the hypotenuse, and this is 25. So now that I have x, y, and r, or hypotenuse, opposite, and adjacent, I can fill them in. So sine is going to use opposite and hypotenuse, so 7 over 25, or y over r. For the cosecant, just flip it, 25 over 7. Cosine. Now, for cosine, it's x over r, or adjacent over hypotenuse, so 24 over 25. Secant is the reciprocal, flip it. Tangent, opposite over adjacent, 7 over 24. And then cotangent, flip it, 24 over 7. You do not need to make them mixed numbers, leave them improper. Always, though, simplify your fractions if necessary. So this is just a review of our geometry days. Again, you can either memorize them as x, y, and r, or opposite, adjacent, and hypotenuse. Now, I'm going to change the numbers here. I'm going to make this a 3 and this a 5. I need to find the missing side. This is the most famous 3, 4, 5 triangle. This shows up on SATs all over the place. Without even doing Pythagorean Theorem, I know it's a triple, and this missing side is 4. But I'll show you what we can do here. So if I needed to find this missing side, I would be doing a squared plus b squared equals c squared. Always remember that the hypotenuse is always your c. It doesn't matter what the 3 was, whether it was a or b. I'll go ahead and plug it in for the b, and I'll solve for a. And then I get a squared plus 9 equals 25. Subtract 9. A squared equals 16. Square root it, and you get a equals 4. Now, normally we've been keeping both the plus and the minus, but here for a side of a triangle, I don't want a negative side, so I just keep the positive 4. But again, you should be able to recognize that when you have a right triangle, and if the hypotenuse is 5 and one of the legs are 3, the missing leg is going to be 4. It's a common triangle that shows up all over the place. Sometimes they'll even scale it up and make it a 6, 8, 10. All right, I'm going to answer all the questions again in relation to angle A. So angle A is up here. So the side opposite to angle A is the 4. Again, opposite is always your Y. The 5 is the hypotenuse. It's also the R. And then the adjacent side is the 3, and that's always your X. So opposite is always Y, adjacent is X, hypotenuse is always R. So again, we're going to answer all the questions in reference to angle A. Now, we could have also done this for angle B. Our fractions will just be switched. So sine of A, opposite over hypotenuse, or Y over R. So it's 4 over 5. Its reciprocal is cosecant. So flip the fraction to hypotenuse over opposite. Cosine, still angle A. This is adjacent over hypotenuse, 3 over 5. Its reciprocal is secant. Flip it, 5 over 3. And then lastly, tangent. This is Y over X, or opposite over adjacent if you're using your TOA. 4 over 3. Reciprocal, flip it, 3/4. So if you want to use the acronyms, this is SO, this is CA, and this is TOA. Either way, or you can memorize what we did with the X, Y, and R's as well. Next, we'll review special right triangles, do a few examples, and then we'll stop here after we do the special rights. My geometry class actually just took a test on this. We just finished trig with the geometry class. Pretty good on this example. Let's move on to the special right triangles. So there's 2 of them. The first one is called the 45, 45, 90, and then the one on the right is the 30, 60, 90. Now, when I would teach this to my geometry class, I would show them both ways. When we're only using special right triangles for trigonometry, we don't have any variables. So the 2 legs in the 45, remember, if these 2 angles are the same, then these 2 legs are congruent. So that's why they're both 1. And then the hypotenuse is always the square root of 2. When we were solving right triangles, when we had numbers other than just 1, 2, and the square root of 2 and the square root of 3, I would teach them to memorize that the side across from 45 was A, and then this was whatever A was with root 2 behind it. But because my A value is 1, I don't need the variables in here. Then for the 30, 60, 90, the side across from 30 is always equal to 1. The side across from 60 will be the square root of 3. And then the side across from the 90, the hypotenuse, that will be 2. Again, when I would teach this to geometry, the side across from 30, I would call that A. The hypotenuse was double that, so 2 times A. And then the side across from the 60 was whatever A was with root 3 behind it. Now, I know sometimes when I would teach this, they were like, oh no, I get confused. Which one gets square root 3? Which one gets square root 2? So one thing that would help me is I look at the 45, 45, and I can see that it has 2 45-degree angles. So that's my clue that that's the triangle that gets the square root of 2. And then over here in the 30, 60, 90, this has 3 different angles. So that's my clue that it's going to have the square root of 3 on one of the sides. Again, what's ever going to help you to remember, just memorize the relationship of the sides. So it wants me to find the sine, the 6 trig functions for the 30-degree angle, and then the 6 trig functions for the 60-degree angle. I'm going to go ahead and redraw the 30, 60, 90 triangle, and I'm going to label my sides based off of each angle. So if I draw first 30, and it doesn't matter where you place the 30 or the 60, what you're memorizing is that the side across from 30 is 1, across from 60 is the square root of 3, and then the hypotenuse is 2. If you want to memorize, again, I'm labeling my sides based off of the 30 for all of these. So here's my 30. So this is opposite, which is also y. This is the adjacent, which is x. And this is the hypotenuse, which is my r. So now, to place them into the 6 trig functions, now that I've drawn the triangle, memorize the sides and what each one is, then I can go ahead and fill everything in. So remember, for sine, if you want to use the opposite and hypotenuse, the trick of so, we're going to fill it in as opposite is 1, hypotenuse is 2. The reciprocal to sine is cosecant. Flip it, 2 over 1. So it simplifies to 2. For cosine of 30, that's adjacent over hypotenuse, so square root of 3 over 2. For its reciprocal, flip it. We can't leave that radical in the bottom. We need to rationalize. So multiply top and bottom by square root 3. And then the final answer is 2 square root 3 over 3. And then finally, tangent. If you want to use your acronyms here, this is the TOA. So opposite over adjacent. This gives you 1 over the square root of 3. I got to rationalize again. So final answer here, square root 3 over 3. Cotangent, flip it. Now, I'm not going to take the simplified answer because then I'd have to go back and rationalize. So what I'm going to do is fill in my reciprocal, which is adjacent over opposite, and then it just simplifies to radical 3. If I were to have taken this, then I'd have to go back and rationalize. It would still give me the same answer. So I was better off going back to what it was originally and flip it there. So this is all 6 trig functions based off the 30-degree angle. Now I'm going to redraw the triangle because now the labels on my sides are in reference to the 60. So let me redraw the 30, 60, 90 here. So 30, 60, and 90. Again, this is still root 3. This is still 1 and 2. But now when I label them, I want to give the names based off their position in relation to the 60. Now the hypotenuse is still always the hypotenuse. Always label him first. Now the side that's opposite to the 60 is the square root of 3. And then the adjacent is now the 1. So you have to look to see which angle they want you to add the labels in reference to. And again, opposite is y, adjacent is x. So now let's fill it in. So again, if you use your SO acronym, this will be opposite over hypotenuse. So square root 3 over 2. Reciprocal, flip it. Rationalize. And you get 2 square root 3 over 3. For cosine of 60, that will be adjacent over hypotenuse, or co, or x over r, 1 over 2. It's reciprocal, flip it. Tangent, TOA, or y over x, square root 3 over 1, simplifies to square root 3. Reciprocal would be 1 over the square root of 3. Rationalize. Final answer, square root 3 over 3. Notice that the sine and cosecant of 30 is the same as the cosine and the secant of 60. If you remember back from your geometry days, the sine of an angle is the same as the cosine of its complement. So, and again, these are also matches here. The cosine and secant of 30 are the same as its complement, which is the sine of 60 and the cosecant of 60. So a review of the 30, 60, 90 and finding the 6 trig function values. Let's do the 45, 45, and then we'll stop here. Go ahead and take a look at the 45, 45. Now, if you realize that in your 45, 45, 90 right triangle here, it doesn't matter which 45 I reference because the opposite and the adjacent are both 1s. So if I label them based off of, say, this 45, this is still the hypotenuse, which is your R. This could be the opposite, and this could be your adjacent. Again, it doesn't matter which 45 I refer to, I still get the same answer. So this is Y, adjacent is always X. So let's fill it in. So again, if you're using your Sohcahtoa, sine is so. So opposite over hypotenuse gives me 1 over the square root of 2. Rationalize. Final answer, square root 2 over 2. For the cosecant, take the original and flip it. So square root 2 over 1 is just the square root of 2. For cosine of 45, adjacent over hypotenuse, well, the opposite and the adjacent are the same numbers. So I get the same thing as above. Rationalize. Square root 2 over 2. Secant, flip it. Square root 2 over 1. Square root 2. Notice these are the same because my opposite and adjacent were both 1. And then finally, tangent. This is the one where when I would have my students check their calculators to make sure they're in degrees, I would always tell them, do tangent of 45 on your calculator. If you get 1, you're correct, you're in degrees. This is something I highly recommend you memorize. It'll make it easier once we start talking the unit circle. So this is the TOA. This was the Ka. So opposite over adjacent, 1 over 1, simplifies to 1. Same thing for the cotangent, 1 over 1, and it simplifies to 1. I highly recommend that you memorize that the tangent of 45 is equal to 1, and the cotangent. So this is where we'll stop. The homework for the 5-3A is just basically all geometry all over again. It's not due tomorrow, it's due on Thursday. Tonight, your homework is just to study for the quiz. You have the review, you have the solutions. And then on Thursday, we'll finish up the notes for 5-3, and then your homework over the weekend will be the 5-3B. However, I'll finish the notes on Thursday, and if you choose to do both A and B homework, you can do that. Your test is a week from Friday, but the quiz tomorrow.